Good morning all. Last day we have learned about evaluation of real definite integrals involving sines and cosines and evaluation of improper integrals. Today we have evaluation of improper integrals involving sines and cosines has to be learned and some problems. This is the theory part. Here the integrals of the type minus infinity to infinity f of x sin ax dx or minus infinity to infinity f of x cos ax dx is there. So we have to evaluate principal value of minus infinity to infinity f of x e raised to iax dx, and which is equal to, using residue theorem, 2 pi a into sigma residue of f of z into e raised to iaz. One statement of Jordan's lemma is pending there. Jordan's lemma is, suppose that a function f of z is analytic at all points z in the upper half plane y greater than or equal to 0. There are exterior to a circle mod z equal to r naught, and CR denote a semicircle z equal to r e raised to I theta, 0 less than or equal to theta less than or equal to pi, where r greater than r naught. Third case, for all points z on CR there is a positive constant mr such that modulus of f of z less than or equal to mr, where limit r tends to infinity mr equal to 0. Then for every positive constant a, limit r tends to infinity, integral over CR f of z e raised to I a z equal to 0. So we have to evaluate this type of problems, minus infinity to infinity f of x sin ax dx or f of x cos ax dx. We know that sin ax is the imaginary part of e raised to iaz and cos az is real part of e raised to iaz that we are using, and we are using we are doing the problem same as in the case of improper integrals. Only case is that we are taking f of z e raised to iaz. Now let's do the problems.
First problem is, if a greater than 0, b greater than 0, show that integral 0 to infinity cos ax by x square plus b square dx is equal to pi by 2b e raised to minus ab. നമ്മളത് ഇംപ്രോപ്പർ ഇൻ്റർവെല്ലിൽ ചെയ്ത പോലെ തന്നെയാണ്. ഇവിടെ ഇൻ്റഗ്രൽ 0 ടു ഇൻഫിനിറ്റി ആണ്. അപ്പോൾ നമ്മൾ ആദ്യം മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി ആക്കണം. അപ്പോൾ അതിന് വേണ്ടിയിട്ട് തന്നിരിക്കുന്ന ഫംഗ്ഷൻസ് നോക്കുക. സിൻസ് cos ax by x square plus b square is an even function, integral 0 to infinity cos ax by x square plus b square is equal to 1 by 2 integral from minus infinity to infinity cos ax by x square plus b square dx, which is equal to 1 by 2 into principal value of minus infinity to infinity cos ax by x square plus b square dx. ഇനി ഇതിൽ ഫംഗ്ഷൻ f of z ആയിട്ട് ഇവിടെ നമുക്ക് cos ax by x square plus b square ഉള്ളത്. അപ്പോൾ cos ടൈം മാറ്റിയിട്ടുള്ള ടൈം 1 by x square plus b square, അതാണ് f of x എടുക്കേണ്ടത്. അതുകൊണ്ട് f of z equal to 1 by z square plus b square. Since f of z is a rational function whose denominator is of degree higher than that of numerator and has no poles on the real axis. The poles of f of z is given by, we can substitute the denominator equal to 0, z square plus b square equal to 0, which implies z equal to plus or minus I by.
Now consider the same contour as the upper half plane of semicircle of radius large r and center at origin. Hence the only pole in the upper half plane is z equal to plus ib. So principal value of minus infinity to infinity 1 by x square plus a square e raised to iax dx is equal to 2 pi I into is residue at z equal to bi f of z e raised to iaz, which is equal to 2 pi I into, this is simple pole, so we can write limit z tends to ib, z minus ib. 1 by z square plus b square can be written as 1 by z minus ib into 1 by z plus ib. So z minus ib cancels and e raised to iz. Now put the value ib. So 2 pi I into 1 by 2 ib. Ib plus ib is 2 ib e raised to ia into z equal to ib. So 2i here 1 2 is there, in the numerator 1 2 is there, I is there, all this cancels, and e raised to ia into ib is e raised to minus ab, I square is equal to minus 1. So pi by b e raised to minus ab. Therefore, principal value of minus infinity to infinity cos ax by x square plus a square dx is equal to principal value of minus infinity to infinity f of x cos ax dx, which is the real part of principal value of minus infinity to infinity f of x e raised to iax dx, which is equal to real part of pi by b e raised to minus iab, which is equal to this is real part itself, so pi by b e raised to minus ab. Therefore, integral 0 to infinity cos ax by x square plus b square plus b square dx is equal to 1 by 2 into principal value of minus infinity to infinity cos ax by x square plus b square dx, which is equal to 1 by 2 into pi by b e raised to minus ab, which is equal to pi by 2b e raised to minus ab, which is the
Next problem is find the Cauchy principal value of the integral minus infinity to infinity x sin x by x square plus 2x plus 2 dx. This is also an improper integral involving sin x. So let f of x equal to z by z square plus 2z plus 2. Remove the sin term and put in z function. Then f of z is a rational function whose denominator is of degree higher than numerator and there is no poles on the real line. So poles of f of z are given by putting denominator equal to 0. So that is z square plus 2z plus 2 equal to 0. So we have the minus b plus or minus b square minus 4ac all divided by 2a. So minus 2 plus or minus square root of 4 minus 4 into 1 into 2 all divided by 2, which is equal to minus 2 plus or minus 4 minus 8 is minus 4 is 2i all divided by 2, which is equal to minus 1 plus or minus i. Consider the contour as upper half plane of the semicircle of radius r and center at origin and the x-axis rotated in anti-clockwise direction. So this is the contour. Then z equal to minus 1 plus i. So it will be somewhere here. This is only lies on contour C. Therefore, principal value of minus infinity to infinity f of x e raised to ix dx equal to 2 pi a into residue of f of z at sigma of residue of f of z e raised to iz. ഇവിടുത്തെ residue നമ്മൾ evaluate ചെയ്യുന്നത് z equal to minus 1 plus i ആണ്, which is lies inside the contour. So 2 pi a into limit z tends to minus 1 plus i, z minus of minus 1 plus i, z e raised to iz by z minus minus 1 plus i, z minus minus 1 minus i. നമ്മൾ quadratic term split ചെയ്ത് എഴുതി. We know that minus 1 plus i and minus 1 minus i are roots. So അങ്ങനെ split ചെയ്ത് എഴുതി എന്നിട്ട് cancel ചെയ്തു. So ഇനി minus 1 plus i substitute ചെയ്യുക. 2 pi i into minus 1 plus i into e raised to i into minus 1 plus i divided by minus 1 plus i minus minus 1 minus i. ഈ ടേമിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു. സോ 2 pi i into minus 1 plus i ഇവിടെ വരുന്നത് e raised to i into minus 1 plus i വരുമ്പോൾ e raised to minus i into e raised to minus 1. This we can രണ്ട് ടേം ആയിട്ട് പ്രോഡക്റ്റ് ആയിട്ട് സ്പ്ലിറ്റ് ചെയ്ത് എഴുതി. ഡിവൈഡഡ് ബൈ minus 1 plus i minus minus 1 minus i. ഇപ്പോൾ minus 1 minus 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 1 അത് ക്യാൻസൽ ആവും. ഇനി ഉള്ളത് i minus minus i 2i. ഇപ്പോൾ ഡിനോമിനേറ്ററിൽ 2i, ആ 2iയും 2 പൈയുടെ 2iയും കൂടെ ക്യാൻസൽ ആയിട്ട് പൈ മാത്രമേ ഉള്ളൂ. e raised to minus 1 നമുക്ക് 1 by e എന്ന് എഴുതാം. സോ പൈ ബൈ ഇ ഇൻറ്റു minus 1 plus i e raised to minus i നെ cos 1 minus i sin 1 എന്ന് എഴുതാം. സോ e raised to minus 1 is cos minus i is cos 1 minus i sin 1. We know that cos theta minus i sin theta. So therefore principal value of minus infinity to infinity x sin x by x square plus 2x plus 2 dx equal to principal value of minus infinity to infinity f of x sin x dx, which is equal to imaginary part of ഇവിടെ sin ആണ് അതുകൊണ്ട് which is imaginary part of principal value of minus infinity to infinity f of x e raised to ix dx, which is equal to imaginary part of നമുക്ക് ഇപ്പോൾ കിട്ടിയ ആൻസർ pi by e into minus 1 plus i. This is not plus, this is minus. This is minus 1 plus i into cos 1 minus i sin 1. ഇതിൻ്റെ ഇമാജിനറി പാർട്ടാണ് വേണ്ടത്. അപ്പോൾ നമ്മളിത് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ പൈ ബൈ ഇ, ഇവിടെ minus 1 into cos 1 അത് റിയൽ പാർട്ടായിരിക്കും. minus 1 into minus i sin 1 which is
പ്ലസ് ഐ സൈൻ 1, അതിൻ്റെ സൈൻ 1 മാത്രം എടുത്താൽ മതി. സോ പൈ ബൈ ഇ സൈൻ 1. മറ്റേ ടൈം അടുത്തത് വരുമ്പോൾ ഈ ഐ വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ പൈ ബൈ ഇ ഇൻറ്റു കോസ് 1. ആ ടേമും റിയൽ പാർട്ട് ഇമാജിനറി പാർട്ടായിരിക്കും. ആ ഇതിൽ ഈ പ്രോഡക്റ്റിൽ 4 ടേം ഉണ്ടാവും, അല്ലെങ്കിൽ 2 ടേം ഇമാജിനറി പാർട്ടായിരിക്കും. ആ 2 ടേം എടുത്താൽ മതി. പൈ ബൈ ഇ കോസ് 1 പ്ലസ് പൈ ബൈ ഇ സൈൻ 1, which we can write പൈ ബൈ ഇ ഇൻറ്റു കോസ് 1 പ്ലസ് സൈൻ 1.